First announcement, Weber State is having their Science Day November 10th from 8:30 to noon. You can register through the Canvas. It's hot linked. You just have to click on it to get registered. We did win the scholarship at that one too last year that we went. So it's a fun one. Same extra credit opportunity for this one. You go, you write up a page, typed, because I don't like to read people's writing sometimes. Typed, Times Roman, 12 font, double spaced, email it to me. Okay? Make sure you tell me your name, your period, and what you're sending me. All right, remember that if you're not here, you come up to Canvas. You have several different periods that you can choose from to get your notes for that day. You have your activity, your quiz, everything that you need is up online. The only thing you can't do up online is your labs, when we do our labs. So today we're actually going to go into type 3 and type 4 naming. Last time we did type 1 and type 2. Okay, I didn't want to do that. There we go. So we're heading into what's called covalent bonding. Type 3, we're going to do a non-metal to a non-metal or metalloid. And then type 4 is naming acids and hydrogen bonding. We're going to do the simple formulas and the polyatomics and more stuff with that. So today, nonpolar covalent, sort of like a tug of war. And then down here at the bottom, we're going to be working with acids. So here we go. First thing, I want you and your person, whoever's sitting at the table with you, to look up here and sort of just observe. What do you see? What the success criteria for this is you should be able to find 2 things about covalent bonding from this picture that you can tell me about. Okay, just looking at this picture. You can talk to your partner. Somebody near you. If you don't have a partner, you can truddy up. I'm not going to give you 5 minutes because it's way too long. What 2 things should you be able to find about covalent bonding? 2 key things. There's a lot of things you can get from that picture, but. Okay, I'll give you 30 more seconds, see what you can figure out. Make sure you're reading signs and all that fun stuff too. Okay, who has one key point they found? Non-metals only, okay. What's another key point? They do. They all have earbuds, and they're sharing an earbud each, right? They don't have 2. They're sharing an earbud equally.
That little guy in the middle is not.
That little guy in the middle? Well, that's true. He's sharing two earpods, but one with each one. Okay? All right. So, success criteria. We found 2 things. They are non-metals, and they're sharing something, whether it be the earbuds or straws, or they're both doing the same kind of thing. I'm not quite sure about him. I just don't know. It's with the guy behind the door. Maybe he's shy. I don't know if he's sharing with somebody there. I don't know. So sharing spreads happiness. If you'll notice, here's the ionic bonds we talked about last time. They've got the guns. Kind of thing. And then we got sodium and copper out here that are metals peeking in evilly. They don't want to share. Okay, so let's talk about what covalent bonding is. First up, it's involving electrons just like ionic bonding is, but the electrons are being shared. The electrons are being shared here. They don't have to be evenly shared, but they are shared. We end up with some of them being what we call polar covalent bonds because the electrons can be pulled closer to one atom than they are to another, but they are shared. I like this little quote here, how chemistry inspired a young Walt Disney.
I do.
All righty then. Okay, so going forward, I need 2 volunteers that are not afraid. 1, come on up. Need 1 more. Come on up.
Oh, yeah, you can't walk.
He can't walk. We need another person then.
Oh, why?
Okay, all right, that works. Okay, so I'm going to have these 2 demonstrate. This has stayed in my mind since I was in college when the professor showed us this, and it's helped me. So I'm hoping to help you. So covalent bonds can do more than just 1 bond, but they can do 1 bond. So go ahead and shake hands. Okay, I'm going to hold this bond in space because this bond would stay in space. But these guys, can you move around that bond?
Yeah.
Move. Okay, so they can keep, okay, go back the other way, go back the other way. So they can move pretty much, and she could come back around here. A single bond is pretty flexible, okay? It's pretty, when something bumps into something, it can still keep that bond, okay? All right, so go ahead and drop that. We're going to do a double bond, and a double bond is going to be 2 hands like this, grabbed. Okay, and I'm going to hold them here. Now, how much can you move around this bond?
Not much.
Okay, show them.
Like maybe in a circle with each other though.
Yeah, you're not moving very much, right? So you are now restricted to what we call a plane. You're in your plane that you can't go 3D. You're only 2D. Okay? Now, I'm going to add another bond to this because covalent bonds can actually make 3 bonds. So I'm going to have you take the same knee on the same side. It's got to touch up off the ground, knee to knee. Up off the ground, up off the ground, up off the ground. Okay, is this a stable? I just put myself on. Oh, no, and you got to keep it going. Okay, this is like TNT. What happens with TNT? If something just bumps it, it goes off. Thank you. I scared her. So it actually releases a lot of energy when it goes off because it's an unstable bond. Did you also know what did they have to do from going from a double bond to a triple bond? What happened there? What did they do? They had to get closer because if they didn't get closer, they couldn't quite reach, and they needed that stability, right? Triple bonds are the weakest bond. They're the easiest to break. Double bonds, what do you think? They are pretty strong. They are really strong, actually. And it's really sort of funny that they're really strong, but they move together. They're moving in a plane. So let's talk about each one of these. So a single bond we show by having just one. I keep having this in the way. We show by having 1 line. That's like the handshake. Okay? So we have our handshake. That is able to move. It has a lot of flexibility. Then we have the double bond. Now, if we would have had opposite up here like this, boy and girl, oh, isn't that sweet? They just have this so cute bond. Yeah, they have a little bit sweeter bond, okay? So they tend to face each other and hold on to each other a little bit more. And this is my very, very best picture of a triple bond. I cannot draw. Okay, this is my best drawing. This is a triple bond, and I told you, I tried, I failed at art, it just didn't work. Okay, this is unstable. Now, if any of you take yoga, there's also a triple bond that's like this. The only problem is that doesn't work in chemistry because see how the bonds have crossed each other? Bonds can't cross each other in chemistry, so that yoga pose doesn't work. But we already know that it's very unstable, like TNT. Okay? So let's talk about how these actually work. If we have 2 oxygens, each of these oxygens have 6 electrons around them, right? So if I connect those 2 oxygens like this, each one would only have 7. I haven't made it to a noble gas. So they're not in noble gas configuration, and so they're not satisfied with each other. So what we have to do instead is we have to share 4 between them, 2 from each of them, so that we can get 8 around each oxygen. Okay? And when we have 8 around each oxygen, then they have a noble gas configuration, even though they had to share 2 from each other. Okay, so that was like the 2 people I had up here. They had to put 2 arms out. Okay, or if we needed to share 6, it would be 3. So when we talk about double and triple bonds, single bonds are represented by a single line between atoms. We can't, and that represents 2 electrons that are bonded. Okay, so we can't just use lines around up here to show these electrons right here because they're not bonded. They have to be shown as dots. But if they're bonded between 2, we show it as a line. Okay, for a double bond, we show 2 lines instead of showing all these dots in the center, because if you start sharing more than 2, it gets a little messy. And you'll see here that I've used X's instead of circles because it got really, anyway, just to show you where the electrons are. Once we get to 3 bonds shared between, we're sharing 6 electrons, and that gets even nastier, so we use 3 lines to show the difference between them. Now, triple bonds are easy to break. They break down to double bonds. Okay? Double bonds are the hardest to break because they've got that love factor. Think of it, you're holding hands like this with somebody you love. Okay? Single bonds are in the middle. Because single bonds, if somebody comes up and comes and hits that bond, even though they're flexible, it's easier to break. Okay? It's like, what's that game that they used to play in elementary school that everybody kept breaking their arms on? Red Rover, and everybody kept breaking arms? Yeah. Okay? All right, so as we're looking at molecules, a molecular formula shows the number and identity of atoms, but it doesn't tell me how they're put together. For instance, you guys know what the formula for sugar is. It is C6H12O6, right? Yeah, glucose. So, but we don't know how it goes together, right? By the way it's said. You have 6 carbons, we have 12 hydrogens, we have 6 oxygens, but how they go together. So we use Lewis structures to show us how things go together. How are they put together? How are they bonded? So, you're going to use colors with me, so make sure you're using colors. We're going to take black for carbon. Carbon has how many around it? 4. So we're going to put 4 dots around it. Okay, hydrogen, we actually use white for hydrogen, so I'm going to use lots of different colors for hydrogen. Here I'm just going to use blue. So blue for hydrogen, how many do I have around hydrogen? 1, and we actually have 4 of them, right? Okay, so as I go to put it into a Lewis structure, I put carbon in the center because it's the least electronegative, and I'll put hydrogen on each side. So this is the Lewis dot structure. I can change that up and show it like this. Okay? When I go to make the molecule of it, or the ball and stick molecule of it, this is what I get. Okay? It doesn't matter which way I flip it, it's always going to land the same. It's always going to look the same. This shape right here is called a tetrahedral. And I'll write that up for you in a minute. And the angle between all of these is 109.5. So, here's my tetrahedral. The angle right here is 109.5, and it's called a tetrahedral. Yeah, it's great when you can grab things from the internet, right? I can draw really well when it's right picture from the internet. Okay, so this is a tetrahedral. So this is a basis for most of the things that we do as a tetrahedral. So let's go on to the next one, water. Oxygen is red. So we're going to do oxygen in red. How many does oxygen have around it? 6. So 1, 2, 3, 4, 5, 6. And we've got hydrogen again. I'm going to do hydrogen as black because it's opposite of black, which is white. So we'll be okay. All right, so we have 2 of these hydrogens, right? Oxygen needs 2, so I'm going to put them in the 2 places where oxygen needs it. So here's oxygen again, 1, 2, 3, 4, 5, 6. bringing in a hydrogen here and a hydrogen here. I could also write it as this. Oftentimes you'll also see water written like this, because if you look at this tetrahedral molecule, two of these are now unshared pairs of electrons. So if you look at it like this, it looks like it's in a line. Can you see that? If the center was red, it would be like it's in a line. But if you look at it like this, it's not, right? It's bent. So we need to know that water actually is bent. Okay? These two other places here that are not shared, they're unshared pairs of electrons. I like to do that because that reminds me of ghosts and Halloween. And I got to remember from this right here that was 109.5 to this right here, the angle is smaller. It's smaller by 2 degrees for each ghost. Okay, and I dropped the 0.5. So what would be the angle? Let's see if I've got that. This angle right here is 2 away for each ghost, so it's 105. And this is called bent. And that did not want to write. That says bent if you can't read that. Okay? All right, we okay to go next slide? No, 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 no. Okay, going forward, we all right? No, still wait. (105° and bent). Okay, we ready to move forward? Okay. All right, so the next one we're doing is hydrogen and chlorine. So I'm going to do hydrogen black with 1 dot, and I'm going to do chlorine green, because usually the halogens are green. So we're going to go 1, 2, 3, 4, 5, 6, 7. This one's straightforward. Hydrogen has 1, chlorine needs 1, so they're going to share. And usually we put the most electronegative last, so I'm going to put that right here with the hydrogen right here. So we would draw it like this. Okay, very simply. Okay, any 2 points are going to be 180, right? So as we draw it over here, it would be a big green and a little white. And of course the angle anytime you have 2 is 180. And it's linear. Okay, next one. Carbon is always black, so we're going to pick black up for carbon. It has 4. Oxygen has 6 around it, and it is red. And we have 2 that are that way. This one takes a little bit of thought. So I have 2 oxygens that need 2, and I have a carbon that needs 4. What am I going to put in the center? Carbon, good. Why am I going to put carbon in the center? Because it can split its 2 to each side, right? So I'm going to put 2 carbon on this side and 2 carbons on this side. I'm going to grab the oxygen. It needs to share 2. So it's going to share those 2. I'm going to put my oxygen. And then these other 2 go out at an angle of 120 degrees because it's like dividing a circle in 3. So they want to be as far apart as they can from each other. So here's another oxygen. like this. So as we look at it, carbon here in the center has 8 around it. You see that? And each oxygen also has 8 around it. So as I'm drawing it, I'm just going to go carbon, double bond oxygen with its 2 unshared pair of electrons, double bond oxygen with its 2 unshared pair of electrons. As I draw it over here though, whoops, I want the red, black first. Black in the center, 2 red dots, 1 on either side. But the bonds aren't straight across, they actually go like this. Let me show you what it actually looks like. This is what carbon actually becomes. And you sort of see it's that tetrahedral in the center, but it's been stretched so it gets that double bond going on. What shape is it? It's linear. It's in a line, right? Not a perfect line because I've been playing with it, but it's a line. So this is linear. And because it's linear, the angle is 180 degrees. Yes?
So, how do you find the ones that are 180?
That aren't 120?
180.
180? Okay, we'll get to more. There's several different angles. You guys are going to be just responsible for the ones I show you. Okay? All right, we okay to move forward? Okay, the next one is nitrogen. We're going to pick up blue for nitrogen. Nitrogen has how many around it? How many does nitrogen have around it? 5. Okay, here we go. 1, 2, 3, 4, 5. And then we got a hydrogen. I'm going to pull the black again for hydrogen with 1, but we have 3 of these. Well, this one's pretty easy. I can look and I can say, oh, nitrogen needs 3. I have 3 hydrogens that each have 1. So my nitrogen is going to be my center. And I'm going to bring in a hydrogen here, and a hydrogen here. So when I redraw it over here, I've got 2 that are not shared, and I've got 1, 2, 3 that are shared. Wait a minute, you just drew that different. Weird. The reason why is that unshared pair of electrons right here at the top actually pulls nitrogen out of the plane. So it actually makes a little pyramid. Okay, so the shape becomes this with its little unshared pair of electrons on the top. Okay, my little ghost. Okay, so my unshared pair of electrons actually scared these other 2 angles down by 2 degrees because I only have 1 unshared pair of electrons. So what was the angle then? So a tetrahedral, what was a tetrahedral? 109.5. This one will scare it down by 2 degrees and drop the 0.5. So just 107. So we drop the 0.5 when we get ghosts. So this angle right here is going to be 107 degrees. And I think I've got a pretty picture. Yep, I do. Okay, so here's my nitrogen. This angle right here, again, 107 degrees. And this is called trigonal pyramidal. Because we do have a square pyramidal, but we're not going to be talking about it in this level. So this is trigonal or trigonal, however you want to say it. Potato, potato, tomato, tomato. Okay. Now, this next one gets a little hairy. So we have nitrogen, which is blue. So we're going to do a nitrogen, and it needs 3. We have carbon, which is black, that needs 4, and we have a hydrogen, which I only have 4 colors, so I'm going to pick green, needs 1. Okay, help me out. What do you think is going to be the center? Which one? Carbon. You're right. Carbon is the center. So we're going to put carbon in the center. Okay, so that means on either side I'm going to have a hydrogen and I'm going to have a nitrogen, right? Now I got to figure out where to put my dots. So carbon has 4. Where am I going to put carbon's 4 dots? Around it, but how? How many does it need to share with hydrogen? It's going to share 1 with hydrogen, right? Because hydrogen has 1 of its own. And hydrogen only needs 2 to be like the noble gas helium. So how many does that leave of carbons? 3. How many does nitrogen need? 3. So carbon's going to share 3 on this side with nitrogen's 3 that it needs. And that leaves how many that are not shared for nitrogen? Where am I going to put those other 2? As far away from the bond as possible. So this is what's going to happen. So redrawing that in just one color, I would get hydrogen is bound to carbon, is triple bound to nitrogen with 1 unshared pair of electrons. So now drawing it. Hydrogen's small and it's white, so we just circle it. Going to carbon, it's bigger and it's black. Going to a nitrogen. Go ahead and open the door for whoever that is. Will you put the magnet in there so that we don't have that problem? Thanks. Okay, and that's our shape. So, oh, I forgot one thing. What did I forget? Triple bond. Okay, so the triple bond, and I do have it made up. So here is what it looks like. Yes? I don't know if I got any more. Doesn't look very promising. I already looked in here, didn't I? See, I might have one on my desk. I don't know how much is left on that one, but... Okay, so here we go with this one. What angle? It's 180. Anytime you have a triple bond, you're going 180. So what shape? Linear. Okay, this one is very stressed. This has cyanide on it. This is hydrogen cyanide, which is also another name for it would be hydrocyanic acid. So this is very stressed. This causes poison in our body because this doesn't like to be that way. It wants to get rid of that triple bond, and when it gets rid of that triple bond, it gives off a lot of energy, which our body doesn't like too much. Okay, so problem. All right, next. Ooh, carbon again. Carbon is black. 4, 1, 2, 3, 4. Sulfur, we're going to use red for sulfur. So 1, 2, 3, 4, 5, 6, because it's like oxygen, it's in the same family. And we have 2 of the sulfurs. Okay, tell me how I'm going to put this together. She says sulfur's going to be in the middle. Now I see carbon's going to be in the middle. Okay, why carbon and not? Because you have 2 sulfurs. Okay, so sulfur on either side, carbon in the center. What am I doing with carbon's 4 dots? 2 on either side, okay. Okay, what am I going to do with sulfur's 6 dots? How many is it sharing? 2, and then I put, where do I put the other 2 sets? So, at a triangle, good. So here, 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 and here, here. So as I drew it, it would be dot, 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 line, carbon, line, sulfur, dot, 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 dot. What shape would this be? Oh, we hear band, I hear linear.
It's the triagonal. Oh, it's linear.
Okay, wouldn't it be like this? It's like CO2, right? The only difference is we're using sulfur instead of oxygen, so it's a little stinkier. Okay, so this is linear, and it's 180. We good to go? Okay, going forward, we are now going to type 3 naming. If you do not know,
Ms. Howell,
yes,
I need J.D. Brooks to come to the attendant's office for a few minutes.
okay.
Thank you.
All right, so if you do not know your prefixes, you need to write these down. 1 is mono, 2 is di, 3 is tri, 4 is tetra, like Tetris. Okay, we don't use quad, we use tetra. And then 5 is penta, 6 hexa, 7 hepta, 8 octa, 9 nona, 10 deca. Most of them should be familiar to you. Mono, if you do a monologue, it's 1 person. Di, it means 2, like dice. Well, tricycle or triangle. Tetra is probably the only one that you're not familiar with. Pentagon, 5-sided. Hexagon, 6-sided. Heptagon, 7-sided. Octagon, 8-sided. Nonagon, 9-sided. And decagon, 10-sided. So these are ones that we're going to use here. You may only use this type. This is my huge big caution here. Because once kids start to learn how to name this, they try to name all chemicals this way. And the only time you can use it is if both chemicals are non-metals or metalloids. So we've got this sort of staircase. Remember boron, silicon, germanium, arsenic, antimony, tellurium, polarium, astatine, and up. Okay, not including the noble gases. You can only have 2 elements. And they both have to be on that line or above. If they're not, you cannot name them this way. Okay? This is my big caution because everybody sees how easy this is, and then they try and name everything this way. Okay? You already know how to do this. What is the name of CO2? Carbon dioxide. What's the name of CO? Carbon monoxide. What are you doing? What are you doing when you're naming them? You're putting a prefix in front of them. Did you put a prefix in front of the first one when you only had 1? But did you put a prefix on the second one when you only had 1? Okay, so here we go. Carbon monoxide, what was it? CO. Okay, boron trifluoride. What's boron? B. Trifluoride. F, and then the 3. Good. Silicon tetrachloride. What's silicon? Si. Tetra. Okay, so what do I do now? Cl, and then the 4 subscript. Good. Diphosphorus. Uh-oh, what do I do here? 2. What do I write? P subscript 2, good. Tetraiodide. What do I do there? Iodine, remember iodine has the top and bottom caps. And then 4 is tetra, good. Quickly do the next 3. Let's see if you do it right. Quickly do the next 3. I'll put them up here in just a few seconds. Here's a hint, guys. Most of these will be where on your periodic table? Upper right-hand corner of the periodic table. Okay, how do we do? Thumbs up, I got them. Thumbs down, I didn't. Have no clue what's going on. And thumbs sideways, I missed a couple. Okay, get it down. We're going to do a little practice here. We got them down. Bottom one's IF7. Okay, so we're going out to poll everywhere. We're going to be doing several polls, so if you bring it up on your computer, it will go faster. So on your computer, you're going to answer the question, what is the formula for disulfur trioxide? Disulfur trioxide. I'm not going to show you the results until we've got 2 minutes. I'm going to give you 2 minutes to get your result in. Okay, as soon as you figure it out, ooh, okay. Give about another 30 seconds and I'm going to show the results. Remember to go ahead and keep that up because I'll put another question up. All right, let's see. You guys did awesome. That is the correct one. S2O3. We had a couple that were wavering there for a few minutes, but you fixed it. Okay, so let's go on to the next page here. Okay, to name a binary acid. So now we're going into type 4. Type 4 is any acid starts with a hydrogen. Okay, so anytime it says something acid, you know it starts with a hydrogen. You're just trying to find out what the hydrogen's with. So binary means what? 2. Hydrogen and something else. So when I have a binary, I just have hydrogen and one other element. So there are no oxygens, and you name it like this. Hydro, the base name of whatever hydrogen's with, ic and acid. Okay, so no oxygens. HF would be what? Hydrofluoric acid, right? So, pretty easy, right? Let's go backwards. Let's see if I give you the name, if you can give me the formula. Yes? HCl. How'd you get that? Hydrogen is hydro, right? Chlorine had a -1. They go together and balance out charges. So we do still have to balance charges. Okay, as long as it's a +1, -1, we just smash it together and it's good. We use hydrochloric acid for tons of things. We'll be using it in lab a lot. So that was one I wanted to make sure you knew. Okay, that's a binary where I just have one element and one element. That just gives us a few of the acids we use. We use acids that have more than 2, and these are called oxyacids. Oh, let's do this one first. So let's see if you can figure out what the formula is for this one. So I'll get this one up. Sorry, I have to activate it. There we go. So it should be activated on your account. Okay, I'm going to give you about another 10 seconds, and then we're going to move on. So just keep this up because we're going to keep coming back to it a lot. Okay, we have a few that have chosen H2IO and H2IO3. Okay, so what was the key here? Hydro tells me what? No oxygen. So I can really quickly knock out the ones that have oxygen. Okay, hydro tells me it's one hydrogen or a hydrogen and one other element. So those of you that did HI, that's correct. And by the way, this is the only acid that will tell you hello and then eat you alive. It really will, all the way through your bones. Okay, all right. I wouldn't try that one again. Nope. Okay, so let's go forward here. We're going to name acids that start with a hydrogen, but if the hydrogen is with a polyatomic, we have a few things. I'm going to give you a little hints on how to remember this. If the polyatomic ended in fight, I-T-E, okay, OS, we're going to get in a fight. So in an acid situation, OS, we're going to get in a fight. So just remember, OS goes with fight. So write this down somewhere because this is your little hint here. There might not be a place specifically, but put it down. So polyatomic ends in "ite", change the ending to OUS. Or if I have an acid that has an OUS ending, I got to remember it was a polyatomic that was ITE. OS, we got in a fight. So I go backwards. Okay, if it ends in "ate", and since Thanksgiving is coming, I love Thanksgiving, but I always eat too much. Because Thanksgiving dinner, I mean, right? There's lots of yummy stuff. But about an hour later, I'm feeling like this guy is, oh, okay? Because no matter how small I make my plate, it seems like it just keeps growing. I don't know about you, but it does that. Okay, so I think of ick, because when it hits my stomach, oh, ick. Okay, about an hour later, I'm just feeling sick. So 8 goes to ick. So if I end up with one that doesn't start with hydro, but it ends in ick, then change that ick to 8 and go look for the polyatomic. Where do I find these polyatomics? On the back of your periodic table. So look on the back of your periodic table, have it open now because we're going to be using it to make these next acids. The first ones are not on your thing, but just stay with me. Okay, here's one to start with. If the polyatomic ended in "ite", changing the ending to OS acid, okay? So here we have H3PO3. Find the polyatomic. What part is the polyatomic? The PO3. So find PO3 on your list of polyatomics. Where is it? Phosphite. So what am I going to name it if it's phosphite? Phosphorus acid. Now I hate exceptions to the rule, but there always is one. Phosphorus and sulfur are notorious for having their own way. So PS, by the way, they get their UR and their OR back because they're special. Okay, just remember. Okay, so here we had PO3, its name was phosphite, it becomes phosphorus acid. Sorry, it's a little down at the bottom. Okay, and it doesn't want to stop spinning. Okay, so if we have one that ends in 8, change it to ick for acid. So we're just practicing a little bit. H2SO4. So look up SO4. What's SO4? Sulfate. So what would it become? Remember PS, by the way, I get my UR and OR back. Sulfuric acid. Good. So if you got that, you're doing great. Now you got to be able to go backwards. If I give you sulfuric acid, you got to go, oh, that's the sulfate ion. It's an acid, so it's with hydrogen. I'm going to balance it. Okay? So let's try one. This is in your notes. Chloric acid. What ion am I looking for? Chlorate. So find chlorate. What is chlorate? ClO3. What's the charge? -1. You got to sort of look at these. They're in columns of charges, -1, -2, -3. Okay, acid tells me that there is a hydrogen. I need to make sure they add to 0. +1, -1. Already do. So HClO3. Everybody okay with that? Okay, let's go to the next one. Chlorus. So chlorus went to what? Chlorite, because, oh, we're going to get in a fight. OS, we're going to get in a fight. So chloride is what? ClO2 negative, and the acid told me there was a hydrogen, right? +1, -1, smash them together, HClO2. You see how that works? So you can go either way, right? Okay, you ready to practice? To see? Okay. Oops, you need to go back? Okay, I'll give you a second while I get over my computer so I can start the next one up. It will ask you the same thing on your pull everywhere. Okay, let's see what we get here. So what is the formula for chromic acid? What is the formula for chromic acid? Oh, it's a race, 50-50. Oh, 33-67. Chromic acid. Ooh, now we got a three-way tie. Oh, nope. I'm just bring it over so you can see what I'm seeing. Three-way tie. Which one is it? It keeps running. Oh, one's beaten now. Hope it's the right one. Okay, last 15 seconds. Put your vote in. Oh, now we got another one coming. Okay, well, let's see. So, chromic, we should have been looking for chrome 8. Chrome 8 is CrO4 with a 2 minus, right? Okay, well, it was an acid, so we know it's going to go with an H plus. Has to add to equal 0. Since it has to add to equal 0, I need 2 of these, right? So I'm going to write H2CrO4. So if you chose that, you got it right. If not, be careful. Okay, going forward. Let me see if I can get forward here. Doesn't want to go. Okay, we got another one going on. Told you we are going to do a bunch in a row here. What's the formula for nitrous acid? I'm only going to give you 20 seconds, so figure it out. Nitrous acid. OS, we're going to get in a fight. Nitrous acid. Five, four, three, 2, and 1. Okay, it is HNO2 because NO2 is nitrite, has a -1 charge, and you need 1 hydrogen to go with it. So C is correct here. Okay, so going forward, now I want you to find out what oxalic acid is. Oxalic acid, and I gotta find my thing again. There we go. And I'll activate that, sorry, just a second. And you only have 2 choices here, so it should be fairly easy. Oxalic acid. And you only have 2 choices because I accidentally pushed the wrong button. And it made me go to the next one. It wouldn't let me fix it. Okay, if you were watching beforehand, you should have known the top one is what? Chromic acid, because we just did that one. So the bottom one is oxalic acid. Even though it has H2C2O4, C2O4 is a polyatomic. It's oxalate. So you do need 2 hydrogens to go with it because oxalate has a -2 charge. Okay, going forward. Now this is a review question. See if you remember from last time how to do this. What is the formula for tungsten IV sulfide? Tungsten IV sulfide. Remember what the Roman numeral tells you. Tungsten IV sulfide. Tungsten IV sulfide. Okay, I'll give you another 15 seconds. I'm going to lock the results so you guys can see and nobody's changed. 10, 5, 4, 3, 2, and 1. Lock it in. Okay, so this is what you guys have. This is what you're telling me. Let's look at what we should be getting. So I'm going to get a blank page here. Tungsten 4 sulfide. So let's write that up here. What does the Roman numeral tell me? The charge on tungsten, right? So tungsten is a W and it has a 4 charge. Sulfide is sulfur, and how far away from the noble gases is it? 2. So we have a 2 minus here. I need it to add to 0. How many tungstens do I need? 1. How many sulfurs do I need? 2, because I need that to be a negative 4. So I need 2 negative 2's to make a negative 4 to cancel out this. So this is what we should have got. Look at what we did get. Okay, so we need to remember what? This Roman numeral right here, what does that mean? The charge on the one before it. It doesn't tell me how many tungstens I have. It just tells me the charge on the one before it. Okay? Remember I told you to beware because you guys are doing what happened there. Okay, so let's go back to the PowerPoint. The bottom one was right. WS2. Okay, so here's another one. Let me get this activated in the other program. But work it out first before you go trying to get it. Okay, it's activated, so anytime you're ready, you can get up there and show me. Try again. There we go. There's some results. Okay, 10 more seconds, and we'll see how you did on this one. 5, 4, 3, 2, and 1. Quickly put your results in and locked. Okay, this is what I got for this one. What is the problem here? You got to be really careful. Nitrite and nitrate are right next to each other on the chart. Nitrate has 3 oxygens. Nitrite only has 2. It is actually the bottom number, which is right. So those of you that pick the bottom, it is correct. But be careful because nitrate is the bottom, nitrite is the top. Okay? All right, let's do the next page here. All right, we're going to do a roadmap, and you've actually got to go to the next page because I know there's not enough room on that page, and we left a big space for you to do a roadmap on the next page. So we're actually going to take a picture of this page and include it this time, and then we're going to be using the back and doing other things. Okay, so first thing we're going to do, and these might come in all different ways, so I'm just going to put them all up, and then I'm going to talk about them. Okay, so you're going to write a roadmap. The first thing is, we're going to give you the names, and you're going to need to write the formulas. We're not going to give you the formulas and have you write the names. So you're going to have to, first of all, say, okay, does it have hydro? If it has hydro, Then you go this way, yes, then it's just hydrogen with one other element. And I got to figure out what that other element is. Balance the charge. If it does not have hydro, that means the anion contains oxygen. That means if it ended in OUS acid, it was an ite as a polyatomic, and I'm looking for that polyatomic to put with hydrogen to balance out the charges. If it was an ick, if it was an ick ending, then it was an 8 polyatomic. So I'm looking for that polyatomic with the 8 to put with hydrogen to balance out the charges. Okay, so you're drawing now a roadmap on how you're going to name. You're drawing that. That's your roadmap. So that first one is, does it have hydro, or yes or no? If it does, yes, then it's hydrogen and one other element. You still have to put them together and balance the charges. If it's no, then it has a polyatomic. And then I've got to look at the ending. Is it an OUS ending, then acid? If it is, then the polyatomic had an ite ending. So change the OUS to ite and go looking for that polyatomic. Then you still have to balance the charge with one hydrogen, or with a hydrogen. It might need more than one hydrogen. If it ended in ick, there was supposed to be one more arrow that went over there. There it is. If it ended in an ick ending, then it was an 8 polyatomic, and I change the ending to 8 and go looking for that polyatomic, find the charge and the formula, and put it with a hydrogen and balance out the charge. So I'll leave that up there for a minute so you can write that down. And you can make it however it makes sense to you, because you're making a roadmap that you're going to make sense of. So we basically have done this in the last several slides. We talked about hydro first. If it was hydro, it was just hydrogen and one other element. If it didn't have hydro at the first, then I know it has to be a hydrogen with a polyatomic. The acid tells me there's always a hydrogen there. So the polyatomic, for the most part, usually will contain oxygen. We're not going to worry about the ones that don't at this point. Remember, OUS, we're going to get in a fight. So OUS goes to ite. And 8 goes to, it goes to 8 because I ate too much. So I'm looking for those polyatomics to put with a hydrogen to figure out the formula. And both the red and the green box down at the bottom basically say the same. So if you can't see the bottom of one of them, it's the same. Okay, so make sure you get a roadmap down so you can get credit for that. Like I said, it doesn't have to be exactly the worded the way I have it up here. You can make it so it makes sense to you, but you got to have some kind of roadmap. Okay, then we're going to go back to the page before, and we're going to do that little grid down at the bottom. So if you want to try using that grid, filling in the grid at the bottom on the page before, if you're done writing your roadmap, and see how well you do as we go along. All you need to do is finish that, and we're done with notes and daily work for today, so then you can upload. So we're going to do some of them together, but I'm waiting till everybody has a chance to write this down. So these are your acids, so you can go through and practice. By the way, what is my positive ion on all of the acids? Hydrogen, H+. So that first column that says positive ion, it's all H+. So that's an easy fill-in for those of you that are ahead. Need to go renumber this so it comes in one at a time on the right numbers. Another 30 seconds, good for those of you that are still writing. Then go back and start to try and do the formulas for the acids. We'll try. So H plus all the way down, positive ion, and then you got to look at the negative ion. Remember, hydro is just with one element. If it doesn't have hydro, you're looking at your polyatomics. Dude, get to work. Okay, going forward here. We did chromic acid, or did we? We did chromic acid already. Yeah. I don't know why that went in there. Okay, so hydrosulfuric acid, keyword hydro. Remember all this coming down is H plus, so if you keep doing that all the way down, you've got it. So hydro means hydrogen and one other element. What other element? Sulfur. Sulfur's how many away from being a noble gas? 2. So I need 2 hydrogens to go with a sulfur, so H2S. That's rotten egg gas. Okay, next one is also a hydro, so that also means just 2 elements. Hydrogen and what other element? Fluorine. What's fluorine's charge? -1. It's 1 away from being a noble gas, so HF. Yes.
You send me a Jacoby to the counseling center.
Okay.
Thank you.
Okay, next one, perchloric. That one does not have a hydrogen, so that means I'm going to go right looking at my polyatomics. Ick went to what? 8. So I'm looking for perchlor8. Find it on the back. What is it? ClO4. Good. What charge? -1. So +1, -1. Just smash it together. That's found in your bleach. Okay, next one. Sulfuric acid. Again, no hydro. It goes to what? 8. Right? It goes to 8. Thanksgiving dinner. So sulfate is what I'm looking for on the back. What is it? SO4, 2 minus. So how many hydrogens do I need to balance it? 2. H2SO4. Okay, nitric acid. Nitrate. So what was nitrate? We did that one already. NO3 with a minus. Good. +1, -1. Smash it together. Nitric acid. Next one has an OUS. OUS came from OS. We're going to get in a fight. So we're looking for phosphite. What's phosphite? PO3 with a 3 minus. Okay, how many hydrogens do I need this time? Need 3. H3, PO3. Okay, keep working. I'm going to put them up on and off as we go here. Give you a chance to do some on your own. Once you're done with this, go ahead and upload it. And if you have not finished the assignment from last time, please work on it and upload it if you need help. let me know. Good. Make sure you do your O's big and then subscript. Okay, so it's not polonium and not cobalt. Doing great though. Got it done? You what? There's some more right next to the Gen Chem in a lid right there. Go grab one. I think that one's ClO2, not ClO3, because it should be chloride that you're looking for. The rest look okay.
So,
Let's get to the minus right there. So this is always going to be hydrogen all the way down on this one. So nitrous, OS, okay, we're going to get a fight, ite, so you're looking for nitrite, which is 2 with a minus.
H2.
Yep. So chlorus, you're looking for chlorite,
Chloride. O2.
minus,
O2.
yep. Hydro means what?
Actually,
Just hydrogen and one other element. So hydrogen and what element?
sulfur.
And sulfur is a,
Negative.
so put a plus here and put a -2 on sulfur. So she actually did that one twice.
So it's the same.
Yep. See if you caught it. Okay, and you only have 2 more to go, so keep going. Get it uploaded. Come on, let's go. Carbonic.
I don't get this at all.
So it came from 8. So look at carbonate. Where's carbonate?
Carbonate.
Yeah, carbonate. So that's what you would write right here. CO3 with a 2 minus or -2. And you need 2 of these to add to a -2 to equal 0, so you put H2CO3.
Oh, that's easy.
And then if it's hydro, it's just hydrogen and one other element, so you're looking for brom, which is bromine. So you're going to BR, and it's 1 OE from being an old gas, so you do -1.
BR plus 1.
Yep, and +1 -1, smash it together.
And then acid. Which one's acid?
The acid is the hydrogen,
Also plus
just HBr. Done. OS, we're going to get in a fight, so we're looking for nitrite.
So it would be NO2 negative.
So
and
+1
plus 2.
no, just H.
2.
No, this 2 is lower. This is all a -1 charge column. So it's the 2 is a subscript.
What?
2 says subscript. It has a -1 charge. So
Oh, so
just HNO2. Done.
H.
Yes, got it. Take a picture of it. Get it up. Yep. So chlorus, look for chlorite.
This one is phosphate.
Yep. Did you have a question, or were you just stretching? Okay.
Oh, I think I was just stretching.
Okay. How we doing? Get it done? Get a picture of it? Get it uploaded? Do it now. Get it done. Let's get some points in. Okay, there's iPads up here if you need to upload, guys. We still got a couple minutes. You can upload it?
I have to upload it when I get it, so I like deleted it, but it still works fine on the web. But like
Okay,
the app is just not.
I'm sorry. So you delete it, did you put it back on? Try putting it back on?
On the website.
Okay. Okay, make sure you've taken pictures of it and put it up. Make sure you've gone through your quizzes. If you have not, you need to. Really quickly, this is what you should have got over here. It's not writing real great over here in the corner, sorry. If I go over it enough times, you might be able to see it. That's H2SO4 on the corner. My what? Oh, my pen fell off. Okay. Yes.
Period's not on for yet for the videos.
Yeah, it died. So just grab one of the other ones and do it. Sorry. I tried to put it up and it went. So that's why I tape every period, just in case. So in fact, I need to stop this.